Hey everyone, and welcome to these lectures on coordinate geometry. Today we're going to start with this new topic. When we finished complex numbers in the previous lecture. So basically what we'll be doing is, first of all, we'll be revising some of the old concepts of coordinate geometry. I'm pretty sure many of you have already done that. Many of you have already have a very good grip on it, but we're still gonna go ahead with starting with the really basic coordinate geometry, so that if anyone has any concept that he's not clear about, or he or she is not clear about, if anyone has just wants to revise that, or just wants to brush up on the concepts, so for that purpose we're gonna start with the basic coordinate geometry. So this is what we'll be dealing with in coordinate geometry. This is all that there is to coordinate geometry. This plane right here in front of you, what you see right here, this is all you're going to see in coordinate geometry. This two axes, x and y, and these numbers around here. You're going to play with these numbers throughout coordinate geometry, no matter how advanced it gets. So what is this plane? This plane basically is called the coordinate plane. It is a two-dimensional surface because we only see an x and y, and they are arranged at right angles to each other. We have a center point that we call an origin. We're going to go through the definitions and the terms in the next slides. These are the horizontal and vertical distances of the point from a specific location called the origin. So these axes, this are basically the distances from the origin. So this is 3 units from the origin, this is 4 units towards the y-axis on the origin. So this is a coordinate plane, and this is just a basic introduction to it. So this is all you're going to do in coordinate geometry. Now as for the terms that we're going to use over here, so I think you're all familiar with it. This is the horizontal axis is called the x-axis. We're going to see how the terms are arranged in the x-axis, and the vertical axis is called the y-axis. The reason I'm going through this is so that just in case, because I'll be using these terms over and over again throughout the coordinate geometry lecture series, and I just want you to be at par with me to understand what I am saying, so that if there are any other different conventions used in any other country that people are watching, so they would know what I'm talking about. So this is an x-axis, this is the y-axis, this is the point that we're going to discuss about. This is the origin, and axis labeling is basically, well, there's nothing to it. It's this 5, 10, -5, -10, -15, and -20. These are called the labels of an axis. So this, you can say, yes, this is axis labeling. The next thing what I want to discuss is the coordinates. So the coordinate plane is basically divided into 4 coordinates. Sorry, I said coordinates, I meant coordinates. The way, this is 1, 2, 3, 4. So the way to understand this is, rather than memorizing which is 1, which is 2, which is 3, which is 4, because this is a convention that you have to follow. What you need to do is that you start from here, that is the right side of the x-axis, the right of the origin, and you go in a counterclockwise direction. And as you pass coordinates, you number them. So in going in the counterclockwise direction, you go from 1 to 2 to 3 to 4. So this is how you have 4 coordinates. This is very, very important in trigonometric identities as well, to know which coordinates are which ones. So this is how we do it. We just remember that you go in counterclockwise direction, and you'll be numbering them like this: 1, 2, 3, 4. This is basically, these are basically the coordinates of a point. So like I explained to you in the previous slide, that we have a point, this is the name of the point, we name it and we number it. We have the x-axis and the y coordinate, the x coordinate and the y coordinate. So this is basically a convention. 3, 4 will basically mean 3 for the x-axis and 4 for the y-axis. Now this is like a universal thing, because this is how how it is represented in all coordinate systems, that you first write the x value before you write the y value. So you can do it either way, but if this is a convention, just go with it, so that if you read any book, you can know which one which is which, and that this is always going to be like this: 3 first, 4 afterwards, that is x-axis first, and 4 y-axis afterwards in any coordinate system. So the thing that we discussed about x and y, basically they're called an ordered pair. Pair because they're 2, and ordered because they have a particular order that you need to follow. So the ordered pair is x, y, and this is how it looks like. The point P, this A over here, would represent ordered pair. It has a name, and along with that it has some points like the x-axis point and the y-axis point. So if you have all three of these, you will say that it is all two and the name with it, we will call it an ordered pair. Another name that is given to the x-axis point, the x coordinate, is the abscissa. Well, this is not really used. This is rarely used, so I am just letting you know, just in case if you want to know, so that you would know what that is. And the y coordinate is called the ordinate. So you don't even have to remember this, because I'm not going to use this, and it's not necessary for you to understand this. So this is pretty much straightforward. Just I wanted to introduce you to these things, and now we move on to what we can do with the coordinate geometry. So the first thing that we're going to discuss is the slope of the slope between any two points. We also call it the gradient. The slope is also called the gradient. So if you have any 2 points, you can say that I want to find the slope from point this to find that. What is the slope from point this to point that? This is how it's used in normal conversation. Or you can find what is the gradient from this point to that point. What this basically is that it measures the change in y with respect to the change in x. That means that if you have 2 points, you're gonna basically treat it as if you had 1 point and then it was shifted to another point. This is how you're going to treat it. But of course, there are going to be 2 points. Like over here you have a point A and you have a point B. Over here represents the triangle, over here represents change. So the change in y over change in x. So you have y2, that is, we're going to call it the second ordered pair that we have, the second set of values that we have, A, and then we have x1 and y1, that is the first value. So how do you know what the change is? Well, obviously for the change we have to subtract the first value from the second value. So y2 will be subtracted from y1. This will represent the change in y, and then x2 will be subtracted from x1. This will represent the change in x. Once you have done that, you will know that this is the gradient of this line, this pinkish line over here. This is the gradient of this line, that is from this point A to this point B. You can treat it as any number. You can treat it as y1, x1 and y1 as the final values, or x2 and y2 as the final values. It won't matter. The negatives, if the answer comes on negative side, that would mean that the gradient is negative. That means the slope is going downwards rather than upwards. So, but of course, don't confuse yourself with that right now, because we're going to discuss this afterwards. Right now, let's look at an example over here. So we need to find the gradient from this point A to this point B. What is the gradient of this pink line over here? So the gradient of this pink line will be, like I said, first we're going to measure the difference between the y values of these, and then the difference between the x values of these. So the difference between the y values of this will be, of course, 4 minus 1, and the difference between the x values will be 6 minus 7. And if you solve that, you are going to get this new answer, which is 5 by 13. So this basically means the change in value of y was 5 and the change in value of x was 13, because this is common sense. If you look at the values of x, you would see that minus 7, if it goes to 6, it will basically have a value of 13. It will basically change 13 values. On the other hand, if you look at the y, if you go from negative 1 to 4, that's negative 1 to 0, 0 to 1, 1 to 2, 2 to 3, 3 to 4. So that's 5 values. So why I'm telling you this is because rather than just memorizing it and rote learning the formula, I want you to know what it really means. So gradient and slope basically means that how the values have changed over time, or basically not over time, basically in coordinate plane. Let's not get into the time factor right now. Another very useful thing that you can do with this is that you can find the missing values of any point. For example, if you have m over here, which is the gradient, so like you see over here, this formula was also represented by m. There's no particular reason for that. This is how it's written in many conventional books. So m would be the gradient, and it would be the gradient from point A to B, and this is the line that represents it. So if you have, let's just say you have a gradient, you know the gradient, you know one point, but you don't know the other point entirely, so you need to find that. Let's just say we need to find y2 over here. So how do we do that? We have the gradient with us, negative 6. Let's just say, it's just as an example, y2 minus y1, we have y1, we have x2 and x1, so we just solve this and we get the value of y. So this way you can find the value of any missing number by the help of a gradient, because that is part of the whole equation. And next formula that we're going to discuss is the length of a line segment. We discussed basically the distance, the slope of a line segment A and B. In this over here we're going to discuss the length of the line segment. So we have 2 points over here, A and B. We have its values x1 and y1 and x2 and y2, and this is how we're going to do that. We're going to treat it like a triangle, and once we treat it like a triangle, we know the Pythagoras theorem, that would be the square of the hypothesis is equal to the square of the base plus the square of the edge perpendicular. So we'll be treating it like this, but the only difference is that rather than having straight values, we have two different values on the coordinate system. So we're going to subtract them, because this is actually not a triangle. We'll be treating it like a triangle to find the value of the length of a line segment. So if you have 2 points, that is, you have A over here and Y over here, the first thing you need to do is you find the distance. To find the distance, you basically subtract this value from this, that is x2 minus x1, and you square it, and then you subtract this value from this, y2 minus y1, you square it, and then you under root it. So this is basically the whole basis of this equation. Just like I showed you the equation over here of the gradient, that is m is equal to y2 minus y1 over x2 minus x1. Remember this equation over here, that is that the length of a line segment of A and B is equals to BC plus AC. So this way, what you can C square, what you can do is that if you have any missing values, you can just plug it in. It is just say like in the previous way that we found out y2 with the help of the gradient. If you want to find y2 with the help of the distance between them, what you can do is you can plug in this whole equation, and AB square would be, you know, the value that is given to you, and then you can find y2 with it, of course, by solving this and subtracting, and then solving the equation, and that way you can find the value of y2 as well. So another interesting thing is that the length of a line segment would basically be the distance from point A to point B. I mean, if the length of the line system over here is 3.5 units, that would basically mean that B is 3.5 units away from A, or A is 3.5 units away from B. So that is how it is. Over here, if you look A and B, we're going to solve it through this we're going to use some examples over here. The same equation we're using, we're using this equation over here. So this one over here, this relation over here, and this is the formula for that. We'll be using that, and you have x2 minus x1 whole square and y2 minus y1 whole square, and you just solve that. So this is the length of the line segment. This is also the distance between the points. So it's pretty straightforward. Like the length of the line segment, like I showed you over here, this is the equation for that. This is the function that we're going to use, and this is how we use it over here. This is how we use it in the example, and this just happens to be the distance between point A and point B as well. I mean, that's just common sense. The next use that I told you of this function is that if you have a missing value, if you have a value of the distance between 2 points or the length of the segment, which is of course the same thing, so what you need to do is you need to plug in the values. If you have a missing x, so you need to plug in the values, and with that you can get the values. You can have this over here, and then 1 minus 3 whole square over here, and you can solve that, and then you can get, of course you're going to get two values of x, because this is a square over here, so you're going to get two values of x. But of course you have to choose one value in the coordinate system. This basically tells you that there are two probable values of x, that they can be two values of x, but of course that depends on the question. What the question is that if it's asking for all possible values of x, or it's only asking for one value of x. So depending on that, you will have to write the answer. The next thing that I'm going to discuss is the midpoint formula. So what is the midpoint formula? The midpoint formula basically is what the name suggests it is. That is the middle point of 22 points. So if, like in the previous examples, we have 2 points over here, we have point A and we have point B. So if we want, we have already found the slope between them, we've already found the distance between them, we have already found the length of the line segment that stretches from A to B. Right now we're going to find the midpoint of A and B. And to do that is we just basically divide it by 2. X, we just take the sum of the coordinates, corresponding coordinates, that is x and y, and then we just divide it by 2. So the corresponding values of x1 corresponding x-axis values of a and b, that is x1 and x2, we're going to take that, we're going to divide it by 2, and then corresponding y values of a and b, that is y1 and y2, we're going to take that and we're going to divide it by 2, and we're going to get the middle point of a line segment. Let's look at an example over here. If you have these points over here, and these are the x values of the 2 points, x1 and x2, so we're just going to add them, minus 2 plus 4 divided by 2 and minus 3 plus 3 divided by 2. That is basically the y-axis values, and once we are done with that, we can get the middle point of this line segment, which would be 1, 0. So this is pretty much it for this video, and we're going to continue with coordinate geometry in the next one. Thank you very much for watching.